Back to our Cambridge Igcse ICT theory, and today's topic is chapter 8, system analysis and design. System analysis and design. So today we're going to look at how how old systems are implemented, they analyzed, they redesigned, or they improved upon, and what are the steps we need to take in implementing a new design or a new system or improving on the old system. The first thing we do when we have operating system, when we're talking about system, we're talking about everything that is taking place in an organization, the kind of system that is used in financial department, the one we're using in manufacturing, the kind of system that is being put in place in an organization. So every system we have in an organization, we have to carry out analysis, we have to do design or redesign, we have to do development and testing of a new one if we need to improve the previous system. We have to implement the new system, and we have to document what we've done, and we have to do evaluations to see how the new system is performing. So in analysis, you go to learn how to describe the different methods that you're going to use to carry out the research of the old system, okay, of a situation, of a system. Then you're also going to learn how to state the needs for recording and analyzing the information that you've collected of your current system. And then you'll be able to state the needs for identifying the features of the existing system and see if there is any need to redesign a new system. And in the design part, if there is need, we're going to state the need for producing the design. Why are we designing a new system? And then we're also going to state and produce the design to solve the given problem, because probably the old system is already giving us problem. If the old system is not giving us problem, there's no need for a new system. So if the old system is already has a problem, then we can ultimately come up with a new system, okay, or a new design. So the sole purpose of a new design is to solve the problems that are inherent in the old system that we're using in an organization. And then another thing in the design we look at is to choose the method of verification, how we're going to be verifying our system. Okay, to prevent, this one has something to do with security, the network security of your system. Your system encompasses the whole operating system, your web design, your database, your portal, and everything that you use it to do your job, you use it to do your work. So you got to think of how you can authenticate them, create password, and protect the system from externality or any vulnerability, as it were. Then after that, after a design, you got to develop the new system. So you design like a skeletal framework, the component, what needs to be put here, the drawings, the mechanization, and every all of this. So we put in place. These are the design. Then after the design is to develop the system. So the development and testing the system that goes after the design. So here in the development stage, you got to understand the system. The system is created from the design. You cannot create a system without designing it first. You have to design the system before you create the system. So you're going to follow your design in creating the new system, and then you test it. Then here also you describe the testing strategy. What are the methods you're going to use to test the new system? And then here also you're going to understand that improvement could be needed as a result of testing. So when you test, you may need to improve. Then you go back to your design to improve the design and ultimately improve the development of the system. The implementation, after you've tested and it's good enough, then we implement. Implement is to learn how to describe the different method of system implementation. Here, we learn how to implement and the method for implementing your new system. Here also, we're going to identify suitable situations for the use of the different methods for our system. And then we also going to learn here the implementation techniques and give it the advantage and disadvantage of every various method that you're going to use for your implementation. Then after that, we go to documentation. When you tested and implemented the system is good, you have to document your system. Okay? So here in documentation, we identify the components of technical documentation. You know, we have technical documentation and user documentation. This one is always in Igcse paper 1. ICT Igcse paper 1. They always ask you about documentation, technical documentation, and they ask you for the language for technical documentation in the exam. You can open the past paper and user documentation. The user documentation is the friendly part, the auto interface when you're working on your system, your network. The one every of the employee uses. They log in and they work, they do their job in the user documentation aspect. In the technical aspect, this is where the programmers, the IT staff, where they do something and do some things to make the system look good. And the language that is used here is different. So these are the back end. The front end is where you have the user documentation. We're going to talk about that. And then before then, we now talk about the evaluations. We evaluate the system to see whether the system is performing optimally according to the design parameters. Okay, explain the need for evaluating the system. We're going to state why we need to evaluate our system and state the need for the variety of evaluation strategies that we're going to use. So these are the steps, stage one by one, that we're going to be following, or the things we need to cover in the whole of this chapter. So we take the first one, the analysis of the system, which is our first part. Okay. First of all, as the name implies, we say system analysis. It means to analyze the system, to look into the system, to see how the system is performing, to see the various stages of the system, the documentation in an organization. So the system that we are talking about, whenever we're talking about system analysis, we're talking about the system within the organization and businesses. Okay, your portal, your website, your database, your portal in your website. You know, the things you do, the management aspect, the various departments, manufacturing. You know, every organization, every company has a website and has a portal and has the whole office work you do and the whole engineering work you do is from the system. So all of this is the system analysis that we're talking about. So the system that makes the organization to work is what we're saying. The system that makes your business move forward. So it all starts with a basic website. Where we plug in, we have so many plugins on the website, like your database. For example, if you say a school system, in a school system, you have the website, you have the portal, you have where students log in, lecturers or teachers log in, parents log in, and all of this. Management, where they log in, accounting, where they do the financial analysis and all of this, financial system, they are all plugged in that website. So this is a system we're talking about. This system makes the organization move forward, right? So all your presentation, your PowerPoint presentation, they are all embedded in the system, okay? So a system is what makes an organization to be efficient. It's what makes an organization to be efficient. Before now, we used to do all our work manually. Now we create software that are plugged into a website to enable the work to be done smoothly, efficiently, and profitably. So this is what we mean by system. So in a system, we have to do maybe what you call the flow chart. We have to design a flow chart. The first one, we look at the research part of a system, the analysis part, the design part, the production part. So this, and then before we move to the testing, documentation, implementation, the B part of it. The testing, documentation, implementation, and evaluation. So the first part, let's take a look at the research part. When you're designing a system or when you're about to design a system, you have to collect information about the present system. If you want a new one, let's say the present one needs improvement, okay? So that website needs improvement. The database needs improvement. Database is not just one. You may have multiple databases that are plugged into the main website. So sometimes they need improvement. The organization is getting larger. Maybe when you design, it was designed for 5 people, but now it's larger. You want to improve it to like 50 people, 100 people working at the same time. So you need to review the old one, collect information about the old system, and then you move to analysis. You examine how the present system works. Because if you want to do a new one, you have to analyze the old one. And by analysis, it means we examine the present system that we're using. We examine it to see how it's working and see the faults, see the disadvantages, see the problems, and then see how to fix the problem with a new design. So after you've seen a problem with the present one, then you make a design of a new system. You come up with a new system that will fix the present system's problem. That's when we move to design stage as a system analyst, or as a system engineer. Because in every organization you have to hire a system analyst, a system engineer, or a network engineer that will do all of it. That both the analyst and the engineer, they will work hand in hand to create the new system. So the engineer will design the new system that will fix the problem that you have with the old system. Okay. Then we move to production. Production is creating the new system from the design. After you make the design, you produce the new system. Okay. You produce the new system. Okay. So that's that. Then after that, we move to testing. Testing is checking if the newly created system is working according to design parameters. Checking if the new system is working according to the design parameters. Then we move, after testing, we move to documentation. Creating documents that describe how to use the new system. You know, you have to create the way how to use it. You now have to make like a manual, how to use the new system. So you have to create the document on the usage of the new system. That's what we call documentation. How to use the new system and how the new system works. So you create how to use and how it works. You create, that's called documentation. Like a manual, you create a manual to enable other people to be able to use the system. You cannot create something complex and you don't create a documentation, how to use and how it works. Other than that, if you don't do that, then it becomes a problem, it becomes difficult for people to use. Then after the documentation, you go to implementation, replacing the present system with the old one. You replace the present system with the new system. You bring a new system to replace the old system. That's called implementation. You implement the new one. You take out the old one. Then evaluation. Evaluation is to check that the new system meets all expectations. The new system that you've replaced, you used to replace the old one is meeting all level, all standard. Okay. Now the first one, we go to the research now in details. We go to the researching the present system, which is the very first aspect of the flow chart. The very first aspect of the flow chart of a system in an organization is to do research of the present system. Now, what are the research, or how do you do research on the present system? How do we do research on the present system? There are different ways of collecting information. Research is to collect information before you go to analysis. Now, how do you do that? Gathering and collecting of information. What are the ways you use? You use observation. There are various ways to collect information. One is observation. You observe the whole system. How it's working, what problem does it have? You observe the whole system. Observation. So please take note. These are always in the exam. This chapter 8, Cambridge, they love it so much. It's always in the exam paper. Okay? So the first thing to do is to observe the whole system and see. Observation, it involves the system analyst working around the organization or business, watching how things work and how he or she own eyes. So with your own eyes, you watch how things are working with the whole system. So observation will allow the system analyst to gather first-hand and unbiased information. Unbiased information, you see the word used? Because here we believe in the probability of concept. In an organization, we believe in probability of concept. So you must not have a biased information. Information, first-hand information, not information told to you. Oh, this staff say, oh, my system is lagging, my system is lagging, my system is this, my system is not good. These are not biased, these are biased information. So as an analyst, you have to have a first-hand information by testing the system, using the system yourself, and see how the system works, and observing the system, okay, so that you can get first-hand information. The downside of observation, this disadvantage of observation as a method, as a technique or method for collecting information is that often people would work the way they normally do if they know that they'll be watched by the system analyst. So this is the bad side of observation, because as a system analyst, you have to be like, you go and observe the users, in the employees of the organization, and see how the system is working. Okay? So observation is to stay with the workers, the employees, as the system analyst, as an IT staff or a network analyst or a system engineer, is to stay with them and be watching them eyeball to eyeball and see what they're doing with the system and how the system is posing challenges to the employees. So the disadvantage of observation is that people tend to work when they be observed. They will not be themselves. They will not work the way they normally work when they be observed. So this is one disadvantage of using observation to collect information. This is one disadvantage because in the exam they ask you the advantage and disadvantage of any of these methods. Advantages and disadvantages of any of these methods. Another method we use in researching about a system is interview. Number 2 is interview. So you can be calling the staff and be interviewing them one after the other, the employees. So the system analyst can interview key people, maybe not all, very key people with integrity within the system to find out how it works, how the system works. So you can be calling them to be asking them salient questions or how it works, the system works. So interview allows lots of very detailed information to be gathered, but this one takes a very long time. It takes a very long time to do because you have to interview a lot of people in the organization. You cannot just interview few people. If you interview very few people, you may not even get the average statistical records of how the system optimally performs. So to know if a system is doing so great, you have to interview a greater number of people. Is that okay? That's two. So we've measured 2 methods of researching and gathering information in an organization as a system analyst. Number 1 is observation. Number 2 is interview. Number 3 is questionnaire. Number 3 is to share questionnaire. You prepare as a system analyst. You have to prepare questionnaires. Okay? You have to prepare questionnaire and share within the organization to the employees and the staff of the organization to answer, to fill them for you. So you can see it looks like multiple choice question. Okay? It may not necessarily be a multiple choice, but a questionnaire looks like a multiple choice question. So here you prepare some questions about regarding the system performance, the problems and everything for the employees to fill. With large group of people, a questionnaire is a quick and simple way to gather information about the system. So when you have very large people using the system in an organization, one of the very good ways to know about the system or to gather information about the system is to prepare questionnaires. So, however, the information gathered is limited by the questions set by the system analyst. So everything you get is what you have prepared in your question. So anything if you forget to prepare your question, you will not get a good clue about that. Because you are not one-on-one with the people. You are not in one-on-one with the people. You are not in one-on-one with the people to be knowing exactly what they are doing. Okay? Or you are not one-on-one with the people to get maybe extra information, because when you interview people sometimes the discussion can go out of the subject matter, like they begin to explain even detail more than what you expected. Okay, that's interview. You get chance to even get a bit of extra information, but in questionnaire you only get what you have asked. It's the question you prepare that the people will respond to. Anything you forget to prepare, you will not get them in questionnaires. So you must, as a system analyst, you must be able to prepare the right questions that will solve the problem. Otherwise, the problem will remain unsolved. So these are some ways we collect information. We say another way is collecting documents. Most business organizations use documents to record information. They use documents like this kind of files, folders. Okay, most businesses and organizations, they use documents to record information or to communicate information. Like they create forms, they make forms and they get the form filled in and passed to the other offices that they have. They create form. Okay, through form you can collect information about the system, right? Now the system analyst needs to collect examples of the documents used to get and understanding of the type and quantity of data that flows through the business or organization. So we've mentioned about 4 ways of collecting information or gathering information. Number 1 is observation, and we stated the disadvantage of observation. We stated the disadvantage of observation, right? We stated the disadvantage of observation. We stated the advantage, we stated the disadvantage. Observation, you'll be there on first hand and you'll be able to watch the employee as they do their work. But the disadvantage is that they may not, once you are with them, they may not work. They may not work the way they normally work. They see you, they pretend to do a lot of work. So you may not be able to get the real and accurate information about the system when you do observation. Number 2 is interview. You interview people, you bring them one after the other to your office as a system analyst. You begin to ask them questions regarding the system and how it works. Interview is a good way, but the only problem is that it wastes a lot of time. You have to spend days and weeks and months interview a very large organization, interview the people in the organization. So that's the disadvantage. Advantage is that you get a lot of information, but the disadvantage is that it's time consuming. Now we go to a questionnaire, which is number 3. Questionnaire is a very good way to get a lot of information. Even if you have 2,000 employees in your organization, you can just prepare a questionnaire and email to all of them to fill and they send back to you. So it's a way, very quick way to get a lot of information. But the problem is that the solution or the answers you get, they are limited to the questions you asked. So there is no room for extra information. Anyone you forget your question did not address, then you'll not be able to collect the right information about that. Another way, number 4, is collecting documents. So we say we prepare documents such as file and folders and forms, and we ask that employees to fill this form, and then we're able to collect basic information about the system. Now let's go to that's for researching about a system. So we say the first one is researching about system, and we say in researching simply means gathering and collecting information. In research, we simply gather and collect information. That's the first stage of system development and system life cycle. Now let's talk about the next one, which is analyzing the present system. So after research, we analyze. After we carry out some research, the next stage is to analyze. Okay? So having collected much information about the present system, the next thing we do is to analyze the system or the information that we've collected. We look at them, we look through it, all the information, and we see how the system works. So after collecting all this information, gathering them, we look through them to understand how the system works. And then, by doing so, when we analyze them, we'll be able to identify some problem that needs to be fixed to improve the system. Okay? If the problems are too numerous, then we have to come up with a new design. Now, this process is called analysis. Looking through the information we've gathered to see what needs to be improved upon or what needs to be kept. This process is called the analysis stage. Now, in the analysis stage, the first thing we do is to identify the inputs and output processes. So we have to look at the inputs and we have to look at the output. What are the things we need to look at that gives us improved system and ultimately gives a maximized organization, a profit maximized organization? Because the whole goal why they hire you as a system analyst, the organization wants to make more profit. So you should be able to analyze the system to see how the system will block loopholes, vulnerabilities, and redundancy, and maximize profit in doing that. Okay? Now, this is because the new system that is designed will have to deal with the similar inputs and output. One of the reasons why you have to analyze the input and output, or you look at the input and output of the old system, is that even if you design a new system, you still have to deal with the input and output for the new system. Let's take an example of a payroll system. We have different systems. Payroll system, the salary system. the one that helps to pay the workers' salary. There's a system put in place. We don't manually pay the salary monthly. So you design a system, you put every 24, the system we create, we check the attendance of the staff, those who did not miss their work, those who missed their work, it will deduct the days they've missed. Not manually, a system put in place. Those who complete all the days they are supposed to come to work, the system will calculate and pay their salary. Okay? So this is called a payroll system. So every business needs to have a payroll system that might help them to do or maximize profit. And in every payroll system, you have the inputs and you have the output. Okay, one of the inputs is employees' time sheet. You have to key in, or you have to. It has to be embedded in the system. The time sheet, like the log in and log out. You know, every day employee come to work, they punch into the system, either using their fingerprint or the retina scan in some organization, or they have some register, like a paper, you slot it to a machine, it will time stamp it, and it will go into the system and it will bring the paper out for you. So it goes into the machine, the computer that you came to work, the time you come in and the time you close. So every day like this for the month. So once you didn't miss, then your full salary will be received. So one of the input is the time sheet, the hour worked. Okay, this one shows the time you came in. Let's say your work is supposed to start 8. Once you come on or before 8, it will time the time, and you're closing by 5. It will also show when you log out or when you time start out. Another thing for the input is the employee's pay rate. What's the employee's pay rate? Every employee have different pay rate because people don't receive the same salary in an organization. So the pay rate, so that we use it to calculate. And that's another input into this payroll system. Another input into the payroll system is the bank account details. So every employee's bank account will be entered into the system. So when you calculate all of this, your hours work and your pay rate, you calculate the monthly wages or monthly salary or the weekly wages or the daily wages. And depending on what that company is doing, it will credit your account and debit the company's account. So they have a system to credit your account and debit this company's account. The bank will implement this because they have a system that is linked with the bank. Okay? So these are your inputs. Now what are the outputs? One of the outputs is the printed pay slip. Every workers at the end of the month, they get the pay slip. A printed pay slip where they take home to keep. And this is one of the outputs. Another output is the EFT payments to employee bank account, or your payment to your bank account from the organization is one of the outputs. Another output is salary report for management, a report sheet for the management to do analysis. So these are outputs you get from a payroll system, and these are the inputs. So for every system, you have the input, you have the output. So we keep this in mind when we design any system. Input, output, to create a better, robust system. Now, a new system that is created also have to take into cognizance all of these parameters, the input parameters and the output parameters. Okay? So because you need all these input parameters. So a pay system, you have to calculate pay. So when you're designing a new one, maybe you improve on the old one, you create a calculator in the new system that will be able to calculate the payment. And then that will, in the output side, I'll be able to print the pay slip, make ETF payment, and produce salary report efficiently and effectively. In the new system, you can see some of the input can go straight to this place. So you have to find a way to upgrade the old system. Okay, so this is for the first one, identifying when you are carrying analysis. The first method of analysis is to identify the input, output, and the processing. The processing part is the brain part, this place. The one you call CPU in a computer. The pay system part. This is the input, this is the output, and this is the processing part. So every system has input, output, and processing part. The next thing to analyze is identify the problems of the system. So you remember we said you create the input or you identify the input, output, and processing. That's the first one for analysis. The second aspect of analysis is to identify problems of the system. No system is perfect. As a result of that, you need to know, as a system analyst, you need to know that you have to be able to identify where the problems are in any system that you are supervising or you're using. Now, if this problem can be fixed, then you fix them as an analyst. You fix them for smooth and efficient operation of the business in any organization that you find yourself, so that the organization will be more profitable, will be more reliable and efficient, and generate more income that will improve the business in general. So we've just looked at the payroll system. Now, if you look at the payroll system, the following problems might be identified. You might begin to note that the payroll often takes over 3 days to process, resulting in many employees' salary being delayed. Okay? It may take a longer time to process. So if that is the case, the payroll is taking the whole system, the employee's salary takes longer time to calculate or to do. So in our new system, we should design an automated calculator. You see, we design automated calculator in the payroll system to fast track the efficient solution to that problem, right? Then another problem that we might identify is that the timesheet sometimes get lost before being processed, because the timesheet is manual. They put it and stamp it, the time you log in, the time you log out. So sometimes it gets lost before being processed. So this means that something has to be done, right? Sometimes pay has to be estimated. You have to estimate the pay because the timesheet is lost, you don't have it. So, meaning the new system we are coming up with, we must find a solution on how to automate the timestamp in the machine. To automate the timestamp in the machine, right? So that we don't have to bother whether the timesheet is lost or not lost. Another problem we might encounter is the report sent to management do not show enough information. The report do not show enough information. So now we have to produce the salary report. Okay, in the old one we just have a payroll system. We assume we get a salary report for management, but this one was not showing a robust report. So we create the report system inside it to generate a whole report of what has taken place, so that management will be able to analyze and fix. Now, after we've seen all of this, we identify the input, output, and the processing part of a system, and we've also identified the problems. The next stage is the new system requirement specification. We now have to sit down and carefully design the requirement for a new system, since we've identified some problem with the old system. So now the problem with the present system are understood. The system analyst has to begin to plan how to fix all of these problems, right? Now the system analyst specifies a list of requirements for the new system. You have to bring out a list of requirements for a new system. So you make a checklist. You make a checklist like this. The new requirement for the new system. Okay? Or the requirement specification for your new system. So for the payroll example we've looked at, we can come up with some of this. We say the payroll processing should be completed within 24 hours. The processing time, the calculated part of the salary should be done within 24 hours. So this is one of the requirements. Then the recording of the hour worked should use a system that means the data cannot be lost. The system should capture it. Then the management report should contain detailed information about the pay for each department, overtime calculation, bonuses, extra time, average hours that is worked, and everything that is done in an organization. Then another requirement that you've noted due to the problem of the old one is that management report should be electronic, so that the managers can analyze the data more easily. Okay, so any system that is designed must meet this requirement. So if you design a new system and it doesn't meet all these requirements, then you are still back to where you were before. You've not solved the problem. Now, another thing you look when you're analyzing a system also is to check what hardware and software will be required. What hardware or software is required for the system. You have to check what are the hardware that is required for the system and what are the software that is also required. Now let's take a look at the hardware. As a system analyst, you must know which hardware are required for your system so that the organization have the adequate hardware for the system for the employee to do their job. How many computers do you need? This is one of the questions as a system analyst you have to ask. And what type of network do you need to build? What type of network or what type of network topology will you need to use? How many servers do you need to have? Okay, how many servers do you need? Then another question, because you need to be able to satisfy the hardware and software requirement. Another one for the hardware is any special devices do you need to bring to the office, like the barcode readers. Okay, the barcode reader, do you need the office need it? If office need it, you must have it. Okay, probably for the pay slip. Then any special output device you need, like the printer and any special other one. There are other big machines that the office might need. You don't have to be going to business center to do some of these things in the office that you are doing from the office. Okay, so these are the hardwares you have to requirement that you as a system analyst you have to check. What about the software? These are always in the exam. The hardware requirement and software requirement. Now what are the software requirements needed as a system analyst? Is ready-made, off-the-shelf software available? Are there software that are available you can just plug in and use? Or is custom-written software required? Do you need to write your own software specifically for the office, or you need to use what they call this, there's a language they use for it, like the one that is already everywhere. You can just plug and use. Okay, is that what you use, or you need to customize your software? Okay, depending on the sensitivity of your office. In many cases, you have to do a custom written software for your organization. And let's take a look at designing a system. What do we need to do? We looked at researching a system, analyzing a system. Now we want to look at designing a system. In the design part, using the list of the requirements that we just talked about, this will help you, the system analyst, on how to design the new system. Because if the old system needs a huge improvement, then you have to design the new system. So the requirement that you just talked about will help the system analyst to design the new system. Now, in most cases, the new system will be computer-based. Maybe your old system was manual, was not computer-based. Now, if you're designing a new system, it has to be computerized. It has to be computer-based. The ease with which computers can communicate and process data means that they are actually the best tool for the job whenever we're working in an organization. Because computer can process and do a lot of work, not like the way they used to do in those days and use the pen and register to do work. Now we use the system. So in the design, one of the first is designing the system input. So you already analyze the input, the output, and the processing. Now is to design the input. So in designing the input, to get data into the system is a two-part process. Data must be captured, meaning it must be collected in a way that then makes it easy to be imputed into the computer or into the system. So data must be captured, and then data must be input into the computer. So two ways. Either you capture the data like using a barcode or something, or you type the data into the computer. There are cases you just scan it, then you capture it, and then it goes into the computer. There are cases you have to type the data into the system. Okay? So capturing, you see, you just bring to the barcode. Like for example, you see nowadays you want to transfer, you just open, you just scan your bank account, everything opens, and then you just transfer. right? So that's capturing. You just capture with a barcode, with a code, a barcode. Just capture all the data once. Once you bring this, okay, if you go to 7-Eleven, they have this. You want to pay bills, you just bring the bill to the 7-Eleven, they bring this bar, they just automated data capture to capture all your data into their computer, and then they will make the payment. Okay, so this capture without typing, without them typing that you want to pay this amount, no. So there's a system now. You just use a barcode. So you design anything, you put a bar. Once they bring this bar, they can scan this, and then every data of this that is hidden here will be captured into the computer. So that's one way. Another way is to type the data. Okay. So we can also have paper form. Okay. Form can be simple ones with spaces for numbers and text to be written in. Now the data from this form would then be typed into the computer, like registration form and so on and so forth. So whatever you fill in here, then the receptionist or whoever is on the desk, we have to type every information you provided here into their computer. So this is two ways of capturing data. Either you capture them or you manually impute them into the system. So this is for the input. The barcode, we've talked about the barcode reader. You bring the reader to read the barcode, and then all the information will be captured into the system. Then we have the card reader also. You just swipe the card, and every information on the card will be imputed into the computer using magnetic stripe. Okay, every card that can do this have a magnetic stripe on it. Another way of imputing data is using camera. Camera can capture or movie images, capture still or movie images, which can then be imputed into the computer. Okay? Another way is using your fingerprint. Fingerprint reader will read your fingerprint and all your information will be imputed into the computer. So once this is done, you've done the work for the input. You'll be able to impute. You design a system that can take various type of input into the computer. Okay, you've designed a system that is robust that have flexibility in getting different input into the system. Now the next is designing on-screen forms and data input. On-screen form and data input. Okay, on-screen form should have all the necessary fields and also have the obvious places where you can impute very useful information into the system. Then after that, we go to the form control. Okay, the form control on-screen forms can have various varieties of controls, such as the buttons or boxes that you can just click, and then information will be imputed into the system. Okay, so all of this helps in capturing data, input data into the system. Okay, now we go to data validation techniques. Data validation techniques in the design stage. So after you've collected data, you have to validate the data. When the data is imputed to the computer, it is good idea for the computer to check that the data is sensible, there's no date of birth in the future. Like, for example, if someone writes a date of birth and he's writing 2025, that's not a sensible data. We are not in 2025, so how can someone be born in 2025 when we've not reached 2025? Okay, so when we say you validate, you check whether all the information that is entered, they are sensible. Meaning, for a good example is, hope no one entered date of birth of the future. Because date of birth of the future has not come. So that's not a sensible data. Now, presence check. Is the data actually present in the field, or has it been missed out? You have to check whether every field the data has been entered into it, or there are some fields where data is being missed out. Data that are very important. That's when you see they say field mark asterisk are very important. When those the check is to the check, you create a system that you check how. meaning the person cannot submit if you skip any of this data. If you refer the person that you tell you the field that are marked asterisk are important, like phone number, like every other detail, that email, they're very important. So when the person skip any of this, it will refer the person back. It will pop up a message. It will pop up a message that will make the person go and validate and check properly. Range check. Okay, a range check is the data value within the set range. Is the data longer or is within the range that has been set for that field? Okay, then length check, whether it's too long or too short. Usually, like for example, password. When they are too long or when they are too short, it tells you the password is too short. You have to make it meet up with the standard. So data check, or the length of data. You have to check whether the length is appropriate enough or not. Then we have type check. Is the data the correct type? You have to check. They cannot ask you to write your name, you are writing your title. Or they ask you to write title, you are putting your name there. They ask you first name, you are writing your family name. So we have all of these, you have to check if these data are in the correct way. Format check. Is the data in the correct format? They cannot, date. They can give you date the way you should write the date. For example, you write day first, before you write month, before you write year. This is the British system. But in American system is the month. You write the month first, before you write the day, before you write the year. So you have to check the format. Did you follow the format? You write the date? Okay, all these have to be checked. So all of these, they fall into the category of what we call the data validation techniques. To validate whether the data were entered properly and so on and so forth. Then we have the data verification technique. Data verification only check whether the data entered is sensible. That's all. Whether the data is sensible. It does not mean that the data is the right data. It's just to check whether the data is sensible. You cannot enter a date. You mean to write 1982, you are writing 1928. 1928 has not come. Your date of birth cannot be entered as 1928. Maybe you mean to write 1982, you are writing 1928. So when you write 1928, this is data verification. So it will take error. So then the next is proofreading. To check the persons compare the original data with the data in the computer. Proofreading. The things you filled in the form, whether they are the same data that were entered into the computer. So this is one way to do proofreading. Then double entry. To check the data is entered into the computer twice. Okay, to check, because your data should be entered twice. So after we've done data verification, the next thing in the design stage is designing the system process. Now we design the system. Okay, now we design the system. Now in any system has to process the data that is given. Okay, so as a system designer, you have to be able to design a system that will process data that is given, not data, unimaginable data by itself. So the first step is designing data and file structure, especially in database. So the type of data and the file structure you want. Any data structure is an organized collection of data. Okay? Organized collection of data is a structure of data, like making a tabular form in a database. Okay? Most commonly used ones are database. You see? To sort out data, you use a database. Okay, now let's take a look at when designing the database, the system designer needs to consider what? The type of data that is being stored, whether they are numbers, they are text, or they are dates. You have to know which type of data that you're being. Then the size of the data, you have to look at size. Type of data, size of data, how long is a typical name going to last, so that you know how to create the field or the length of the field. Then the field names to use. So you know whether you should use name here, you should use date, DOB, date of birth, phone number, class, and so on. The field names to use. And how many records will need to be stored, right? How many records do you need to be stored? Okay, so all of these are very important. Okay, now the designer also need to consider which backup storage or media he needs to use. Okay, the backup storage. You know you must back up your data. Okay, maybe Google Drive, maybe Thumb Drive, maybe Flash Drive, maybe floppy disk. You must determine how to back up your data. How often will the data need to be accessed, and the type of backup storage you need depends on how often the data needs to be accessed, and how quickly the data needs to be accessed, and how large the data file is. So these three parameters determine what kind of backup storage you need. Okay. Then after that, designing how the data will be processed. You have to design how the data will be processed, the type of algorithm. Of course, the system designer needs to design the actual steps to be followed by processing the data. That's the algorithm. The actual step, follow the flow chart, the algorithm. Now, this part of the design is outside the scope of the Igcse. We are not going to go into this. Okay, the algorithm is for higher studies. But you just need to know that you have to design how the data will be processed. Okay, but the processing algorithm is outside your scope. It's for university programs. That's where you learn coding, programming, deep coding, deep programming, using different languages, and so on and so forth. Okay, now the next thing is designing the system output. Now, here you look at the on-screen report and printed report. The on-screen is when you are viewing it from the monitor, the computer. Okay, the on-screen report. The printed report is a hard copy that you mail or you file and put your files and folder. Okay, now let's look at designing on-screen report, and then we look at designing the printed report. So when you're designing the on-screen report, this will be similar to designing an on-screen form that we've talked about in the input side. There are a number of things that you need to consider when you're designing the on-screen report. One is show all the necessary field. All the necessary field that needs to be entered in the database. Then how fields that are right size. You have to create the right size of every field. Some needs to be a bit longer, some needs to be shorter, depending on the field names or whatever data needs to be entered on that field. The next one is how easy you have to have an easy to understand instruction if needed. Then another thing you need to consider is to make good use of the screen area whenever it's available. Then another thing is make good use of the colors and the fonts to make the data clearer to people. Okay, the color, the font, and everything. So here is an example of employees detail. This is the ID number, the employee's ID. This is the name. This is the son name, that's the family name. And this is the gender. And this is the date of birth. Okay. And this is the department he works in, the organization. He works in the account department. You can either print the record or click done. Okay. Now designing printed report. This on screen. So it brings all the information out for you on the screen. On screen report. But printed one, designing a printed report. Here, designing a printed report is just like designing an on-screen report, except that the report needs to fit in the piece of a printer, a printed paper. So when you design this has to be able to fit. You check the preview and be able to fit on the printed paper, and you'll be able to print. So I think with this we come to the end of this. Next class we'll be looking at testing the new system. We look at testing, how to test the new system.